For today, I know I mentioned this yesterday. Everything is kind of building. So yesterday we just focused on the linear programming process, and now today we are applying it. So everything you did yesterday, you are also doing today, except you are using it as a specific scenario. So the inequalities and the function will not be given to you. You have to write them based on the situation you're given. So this process is not just called linear programming, but it's called optimization, where you're seeking a max or a min for a quantity. So officially, well, I guess by definition, to optimize, it says on the top, means to seek the best price or amount in order to minimize costs or maximize profits. And it's often obtained with the use of linear programming. So these steps that are listed here, what I want you to realize is this is the breakdown of everything you did yesterday. However, what you didn't have to do yesterday was in step 1, define your variables. In step 2, write a system of inequalities. And then in step 5, write a function to be maximized or minimized. Those were given to you. The rest of the steps is what you did yesterday. So when we go through this, I have one example to go through with you. When we go through this, I'm going to number the steps. I am going to combine step 5 and step 2 just so we write everything at once, write the system of inequalities and write the function right away. And then we can go ahead, graph the system, find the coordinates of the vertices of the feasible region, substitute the vertices into the function, and then answer the question. So one last thing before we get to the example, it does say when you're using a system of inequalities to describe constraints in a real-world problem, often only whole number solutions will make sense. So the problem that we're going to be working with is talking about jewelry, and if you're thinking solution-wise, having half of a necklace isn't going to make sense. That's really what that statement is saying. Another thing I want to add, though, back up in step 2, is all of your systems of inequalities that you write should include these two inequalities. X and Y should both be greater than or equal to 0. Sometimes these are already included in the problem itself. If one of the inequalities you write, for example, is that X should be greater than or equal to 5, then you don't have to include greater than or equal to 0 because it already would be. But this basically is just telling you we're only looking at positive values, so your graph should be in the first quadrant. So it's not necessarily anything additional you would need to graph, but it should be part of your system if it isn't kind of built in already. So we're going to look at this one example, and as we read through this, kind of think to yourself, we're going to have to define our variables, so what would it make sense for X and Y to represent? We're going to be writing a system of inequalities and a function. So it says each week, Mackenzie can make 10 to 25 necklaces and 15 to 40 pairs of earrings. If she earns profits of $3 on each pair of earrings and $5 on each necklace, and she plans to sell at least 30 pieces of jewelry, how can she maximize her profit? So in step 1, we are defining our variables. I'm going to use X and Y, but what does it make sense for X and Y to represent in this situation? Necklaces and earrings. So I'm going to let X be the number of necklaces and Y number of, I'll put pairs of earrings. Typically you think of earrings in a pair anyway, but just specifically it's not talking about an individual earring. And then I'm going to do, according to the box above, step 2 and step 5. I'm going to write the system of inequalities and the function. And what I want to point out is, because in this case, the information was all given together. One of the examples on your assignment is going to give information kind of in separate steps. It has, part A, part B, part C. And so it'll give you the function information separately. But in order to pick out from all the information we have what should go with the inequalities and what should go with the function, ultimately, she's trying to maximize her profit. So our function should represent the profit. It should be the profit function. If I read through this information again, it's saying that her profit on each pair of earrings is $3 and $5 on each necklace. So the 3 and the 5 should be part of the function and not part of my inequalities. So because I'm talking about the function, I'm going to write that first. I'm just going to leave some room above for my inequalities. But the function will be f of xy. And if she's making $3 on each pair of earrings and $5 on each necklace, and make sure you have the variables correct for how they're defined, it would be 5x plus 3y, or 3y plus 5x would be fine too. But kind of picking out what should go with your function versus your inequalities. And typically, your function is going to represent a profit or a cost. So any dollar amounts you're given are going to be going with your function, in most cases. So now if I go back up and look at the rest of the information to write the inequalities, it says Mackenzie can make 10 to 25 necklaces and then 15 to 40 pairs of earrings. So anybody have an idea if x represents number of necklaces, how I can represent that she can make 10 to 25 necklaces? How could that be written? Grace? For necklaces would be x. 25, yep. And if you had these defined like the opposite, that's fine. You would just need your variables opposite from how I'm writing them up here. So yes, x should be in between 10 and 25 if she can make 10 to 25 necklaces. And then we can write a similar component inequality for pairs of earrings with y. Y should be in between 15 and 40. And then I can skip over the profit information. She's planning to sell at least 30 pieces of jewelry. So altogether, she would need to make at least 30 pieces of jewelry. How could that be written as an inequality? Yes. At least would be greater than or equal to. So her total number of necklaces and earrings should be equal to 30 or more than 30. All right, so here's our system. This was like exactly what you were given yesterday. Here's our system. Here's our function. Everything we do after this point is what you did yesterday. So we want to graph our system of inequalities. Also, I do want to point out in this specific example, we do not have to include the x and y are both greater than or equal to 0 because that's already implied here. If x is greater than or equal to 10 and y is greater than or equal to 15, we know they're greater than or equal to 0, so we don't have to include them with this one. So I'm just going to draw in my two axes. And this graph is not pre-scaled for you. So looking at the values we have in our inequalities, what scale would make sense? If this is 10 by 10. So counting by ones doesn't make sense. We could count by fives, and actually for both that would be okay. That'll get us to 50 for both x and y. Just make sure if you're ever making your own graph, if you're not counting by ones, that you include what your scale is. And then we can go ahead and graph. So I'm going to look at the first compound inequality. So remember the x between 10 and 25 represents two different lines, and are they horizontal or vertical lines? Vertical. So I should have a vertical line through the x value 10 and the x value 25. And where would the shading be for those two lines in between? And then similar process to graph y between 15 and 40. Now these are horizontal lines, so a horizontal line through 15 and 40. Shading would be in between. So right now with these four lines, we're looking at our shaded region being that rectangle. But we have one last inequality to graph. So the last one, I can get this in slope-intercept form, subtract x from each side. So y is greater than or equal to negative x plus 30. And that way I can plot my y-intercept of 30. And my slope is negative 1 over 1. So even though my scale is by 5s, because my x and y axis have the same scale, I can still go down 1 even though it's really down 5, and then right 1 even though it's really right 5. It'll work out the same graphically. And that one I would want to test 0, 0 to see, am I shading below the line, in which case I would have this tiny little triangle here, or above the line, in which case I have, well, a 5-sided figure. But if I test 0, 0, I'll test it in the original. I get 0 is greater than or equal to 30, which is false. So that means I want to shade above the line. So I have this 5-sided figure as my feasible region. And that was really step 3. That was the graphing the system of inequalities part. Questions on that graph? Okay, so then next I'm going to combine kind of what they say are steps 4 and 6. But again, this whole thing now is what we did yesterday. So steps 4 and 6 now say you're finding the vertices of your feasible region and substituting them into your function, which we already wrote. So how many vertices do we have? 5. So what is one of them? 10, 20 is one of them. And another one. Ethan? 15, 15. And another. 25, 15. Two more. We have the two top ones. 1040. And the top right one, 2540. Okay, and these are now being substituted into our function. The f of xy is 5x plus 3y. So if we have 1020, that means we have 5 times x is 10 plus 3 times 20 is y. and that's 50 plus 60, so that's 110. 15, 15, so 5 times 15 plus 3 times 15, that would be 45, or no, yeah, 75 plus 45, so 120. Five times 25 plus 3 times 15 for the next one. 125 plus 45, that's 170. 5 times 10 plus 3 times 40. 50 plus 120 is also 170. And then 5 times 25 plus 3 times 40 would be 125 plus 120, so 225, or no, 245. Questions on that part? Okay, so here's what you need to then check. This is going to be a little different from yesterday. The very last step is actually answering the question. You are not picking out necessarily what the max and the min are. You have to look at what the problem wants you to find. It does not just ask you what her maximum profit is. It says how can she get a maximum profit, or how can she maximize her profit. So if for this question you just said her maximum profit is $245, you did not answer the question. It says how can she earn that. So that's where you look at where the maximum occurs. X is 25, that's her number of necklaces she's selling. 40 is her Y, that's her number of earrings. So we could answer this and say her maximum profit is $245 for selling, so this is the how part, for selling 25 necklaces and 40 pairs of earrings. Okay, so it really should be answered in a sentence. Most of the time, it's not just asking you for the maximum or minimum. It wants to know how that is achieved, what needs to happen to get the maximum profit or the minimum cost if it's talking about a cost.